All right, chemistry, this is your video lecture for chapter 7, section 1. We are talking about chemical names and formulas. That's going to be the crux of this entire chapter. But for section 1, your objectives. Explain the significance of a chemical formula. Why do we use the chemical formula? What information is communicated by the chemical formula? That's what we're getting at when we say explain the significance. Determine the formula of an ionic compound formed between two given ions, and name an ionic compound given its formula. So going both ways. If I give you a formula, you'll be able to tell me the name. If I give you the name, be able to tell me the formula for an ionic compound. Then using prefixes, which is a different naming system, name a binary, meaning there are two objects there, two things bonding. Molecular compound, and again here molecular referring to covalently bonded atoms. Name a binary molecular compound from its formula, and then write a formula of a binary molecular compound given its name. Again, going both ways, from the formula to the name and from the name to the formula. Now, a chemical formula indicates the number and indicates the kind and relative number of atoms in a chemical compound. When you look at this sugar I have over here, we have C3H5O2. There are 3 carbons. There are 5 hydrogens, and there are 2 oxygens in this particular ratio right here. So I get the kind of atom, and I get the relative number. For example, octane, C8H18, okay, the additive to gasoline, has 8 carbon atoms and 18 hydrogen atoms. Now, for the most part, you guys can already read this fairly well, but again, that is the significance of the chemical formula. So moving on to the ionic compounds, being able to go back and forth between the name and the formula and the formula and the name. Compounds that have the elements held together by ionic bonds are called ionic compounds. Remember that from last chapter. For an ionic compound to exist, let's also remember this: the algebraic sum of the positive and negative charges of those ions must equal 0. Remember, it has to be a neutral molecule overall. Okay, the magnitude of the charges have to be the same. For instance, when a calcium atom becomes an ion, it has an overall +2 charge, which must be neutralized by ions that have a -2 charge. If a calcium ion forms an ionic bond with an oxygen anion or oxide, the resulting compound will be neutral, and the formula would be CaO. However, if the calcium ion bonds with a fluoride ion, it would require 2 fluoride ions to neutralize the calcium 2. So in order for this to be an ionic compound, it would be CaF2. We need 2 of the fluorines. Now, there are 2 different types of ions. We have monatomic and we have polyatomic. For example, on the back of your periodic table, you have a polyatomic ion sheet, so you can get used to the names of different polyatomic ions. But the opposite of poly is just mono, right? There's just one atom. Okay, ions form from a single atom. If the ion has a positive charge, simply use the name of that element. Like in the last slide, we said calcium ion. If the ion has a negative charge, replace the ending of that element's name with IDE, like fluorine became fluoride. Hopefully you remember that from last chapter. Now, a binary compound sounds like a very fancy thing, but it's just a compound consisting of 2 elements. Binary, 2 things. So when we go to write a binary ionic compound, we write the symbols for the ions side by side with the cation ion first, the positive thing first. If the charges of the 2 ions do not add up to 0, and this is a trick here, okay, this is a trick, cross over the charges by using the absolute value for each ion's charge as the subscript for the other ion. Okay, so take the charge, absolute value. So if it's a negative charge, don't bring the negative sign, but just absolute value of the charge, and put that as the subscript for the other ion. Now, we'll get to an example. I'll show you what I mean here. But looking at, for example, aluminum oxide, in order for aluminum oxide to be a real ionic compound, it's going to have to be Al2O3. Now, we are talking about nomenclature, which is a naming system. We have to name these things. We can't simply look at formulas and not have anything to call them. We need to call them by name sometimes. So write the name of the cation first. Write the name of the anion second. For example, I'm looking at this. I have Al2O3. Aluminum is the first element, so I write aluminum first. It's the positive cation. And then obviously oxygen is the negative anion. I write that first. Second. All right. Some practice problems that apparently my animations are off, so you already see the answers. Okay, so I guess we won't be pausing and seeing what we can come up with here. But when we take magnesium, which is a +2 because it's main group 2, and chloride, we would need MgCl2. We would need 2 of these singly charged anions to balance out the doubly positively charged cation. If we're going to do sodium and sulfide, it's going to be Na2S because the sulfide is a -2 charge. Sodium is just a +1. Aluminum sulfide is Al2S3, okay, because the aluminum is a +3. Sulfide is a -2. Looking at it from the other way, going from formula to name, start with Ag, that's silver, and chloride. Zn is zinc. This is an oxygen, so oxide. Calcium, and this is bromine, so bromide, calcium bromide. All right, there is another system for naming things, okay, and we are going to use this in certain ionic compounds, only certain ones, okay, and it's going to happen for most transition metals, okay, so hold on, the stock system. Now, the reason we have this stock system is because some metallic elements form cations that have more than one charge. They have more than one charge. For example, chromium, cobalt, copper, iron, lead, manganese, mercury, nickel, tin form multiple charges. It's not that they're always +2 or always +3. Sometimes they're either one, either or. So for cations that have multiple ionic charges, we need to place a Roman numeral in parentheses that is equal to the ionic charge after the name of that metal. So if I have the copper, the type of copper that's +1 charge, I write copper, parentheses, Roman numeral 1, in parentheses. If it's copper, the type of copper that's +2, I write copper, parentheses, Roman numeral 2, in parentheses. And I'm going to stick that into that binary naming system that I was already using. Okay, the rules for the anion, exactly the same. Okay, exactly the same. I just need to indicate what charge this transition metal has by the Roman numeral. So, when using the stock system, here are your steps. Write the formula for the ionic compound. Use the charge of the anion to determine the charge of the cation. Write the name of the cation with the charge followed by the name of the anion. So, examples. Copper chloride. Okay, I said CuCl. I see that there's only one chloride. So if there's only one chloride, does a total of a -1 charge? That means that there has to be a total of a +1 charge. So this must be the type of copper that has a +1 charge. So it's copper 1 chloride. And that's how I say that, copper 1 chloride. However, if I see that the formula is CuCl2, there are 2 chlorides. Each chloride has a -1, so it's an overall -2 charge. So the copper must be bringing 2 positive charges, right? So this must be the type of copper that has a +2 charge. That's copper 2 chloride. All right. Now we have some practice problems that we actually got the animations correct on. So go ahead and press pause and see if you can write both the formulas for each of these and the names for each of these. Go ahead and press pause now. All right, let's see how we did. First up, calcium and bromide. What type of what type of copper is it? Well, it's indicated that it's a copper that's +2. Okay, so it's going to be copper 2 bromide. Bromide has a -1 charge, so I'm going to need 2 of those to balance out the copper 2 bromide. CuBr2. I got iron, that's a +3, and I got oxygen, that's a -2, obviously. So it's going to be some sort of iron oxide. But the question is, what is the Roman numeral behind iron that I'm going to write? Well, I'm going to write iron 3 oxide because that iron has a +3 charge. Same thing with this lead right here. What am I going to write? It's lead with a +4 charge, so that's lead 4 chloride. Now, if we don't know the charges, okay, because these charges up here aren't going to be included all the time. I already put the next one. Copper 2 oxide. I know that oxygen is going to have a -2 charge, so there must be a +2 charge given by that copper. So copper 2 oxide. This next cobalt fluoride. There are 3 of them, each of them giving a -1, so there must be a total of 3 negative charges that have to be balanced by 3 positive charges, so that's going to be cobalt 3. We have tin and iodine getting together. There are 4 iodides, so that's going to be a total of a -4 charge overall. So I'm going to need 4 positive charges coming from tin, so tin for iodide. And then from that sulfide, giving off a -2, so that iron must be balancing that off with a +2, so iron 2 sulfide. Moving on to polyatomic ions. A polyatomic ion is a group of covalently bonded atoms that have an ionic charge. Here's another one, oxyanion. It's not that difficult. It's a negatively charged polyatomic ion that has oxygen, oxyanion. So, ionic compounds and polyatomic ions. Writing and naming strategies are the same for ionic compounds with polyatomic ions. However, if more than one polyatomic ion is needed in the formula of the polyatomic ion is placed in parentheses. Remember the parentheses. And a subscript is used outside the parentheses to show how many of the polyatomic ions are needed. For example, if I have like iron 2 nitrate, I'm going to take the nitrate, which is NO3, and I'll place that inside some parentheses. Now, looking at your polyatomic ion sheet, you can see that nitrate has a -1 charge. And this type of iron, it's iron 2, so it has a +2 charge overall. So I'm going to need 2 nitrates to balance out that positive charge. Now, I can't simply put that 2 right behind the 3, because then that'll look like NO32, 32 oxygens. So I'm going to put the 2, the subscript 2, to indicate that there are 2 nitrates. I'm going to put that outside of the parentheses. All right, guys, that's going to do it for this video lecture. We've gone over the significance of chemical formulas as well as ionic compounds and how we write their formulas and write their names. Next lecture, we'll go over binary molecular compounds, how to write their formulas, and how to write their names. All right, guys, I will see you next period.